In this video, we're going to be covering forces. Now, what is a force? A force is a push or a pull that can change an object's motion. Forces can make something speed up, slow down, stop, or change direction. Even when an object isn't moving, forces can still be acting on it. Forces are at work around us constantly, and understanding them helps explain many everyday situations. In this video, we'll go over the main types of forces, including gravity, normal, and applied force, and look at how each one affects motion. We'll also connect these ideas to Newton's 3 laws of motion, which describe how and why objects behave the way that they do. Gravitational force is the pull between two objects with mass. On Earth, we mostly notice gravity pulling everything towards the ground. This force is why objects fall, why we stay on the surface, and why things have weight. Its direction is always downward towards the center of the Earth, and its strength depends on the object's mass. More mass means a stronger gravitational pull. Normal force is the support force from a surface that pushes back on an object. Whenever something rests on a surface, like a table, floor, or chair, the surface pushes upward on it. This keeps the object from falling through. Its direction is always perpendicular or 90 degrees to the surface, and its role is to balance the gravitational force on an object. You can't feel normal force directly, but it's what allows objects to stay in place instead of sinking into the floor. Here's our first real-life example, a tech deck at rest on a desk. Even though it is not moving, two forces are acting on it. Gravity pulls the tech deck downward, that's our downward arrow. At the same time, the desk pushes upward with an equal force called the normal force. These two forces balance each other, so the tech deck stays perfectly still. No motion happens because the upward normal force and the downward gravity force cancel out. Balanced forces happen when all the forces acting on an object are equal in size but opposite in direction. Because they cancel each other out, the object's motion does not change. Unbalanced forces occur when a force is stronger than the others acting on the object. Because they don't cancel out, the object's motion does change. This can cause an object to speed up, slow down, start moving, stop moving, or change direction. Next is applied force. Applied force is any push or pull that comes from a person or another object. This is the force you intentionally create when you move something. Its direction depends on how you push or pull, and its strength depends on how hard you apply the force. Here's another real-life example with our tech deck, but this time it's rolling across the surface. As it moves, 4 main forces are acting on it. Gravity pulls the tech deck downward, the downward arrow. The surface pushes upward with the normal force, that's the upward arrow, balancing out gravity. The push on the tech deck is the applied force that makes it move forward. And friction acts in the opposite direction of the motion, slowing it down as it rolls. So while the tech deck travels across the surface, these forces work together to change its motion. Now let's go over Newton's 3 laws of motion. Newton's first law says that an object at rest stays at rest, and an object in motion stays in motion unless acted on by an unbalanced force. Newton's second law states that the acceleration of an object depends on its mass and the net force applied to it. Now I'm going to show 2 videos with the same massed object. One is going to be with the slight push, and the next one is with the bigger push. Newton's third law says that for every action, there is an equal and opposite reaction. In this example, you can see the tech deck rolling down the sign into the backpack. It pushes on the backpack, and the backpack pushes back with an equal and opposite force. This is also a good example of normal force, gravitational force, and frictional force all at work. Thank you for watching. We hope you learned something new about forces and how they show up in real-life examples.